So we're going to continue our work with section 2.5 today on transformations. Before break, you guys went into Desmos and did some investigating about what the different transformations look like. All right, so if we have an A value here, what is it going to do? What kind of transformation does that A value have? I heard stretch. Could be a stretch or a compression, or what else does A do? It can reflect it. What would make it reflect it? If it's negative, yep. So we're not going to look at the negatives right now. We're just going to look at the stretching, compressing idea. But if A is negative, it reflects over the x-axis. Okay. So I want you to watch the graph as I move the slider here. So as A gets bigger, what happens? It's a vertical stretch, yes? So take a look at your y coordinates. When we talk about a vertical stretch, we're saying we're taking our y coordinates and we're multiplying them by whatever A is. So I made A to be a 2. That means all my y coordinates should be doubled. So here I'm at a height of 1. When I double it, I'm at a height of 2. Does that make sense? We're just stretching our y values. Our x value doesn't have anything done to it. Our y values just get taller. What happens as A goes smaller than 1? Now we have a vertical compression. Okay, so right now I have my slider set at 0.4. So my y coordinates are going to be 4/10 of what they had been. Okay, so again, we were at 1, now I'm down at 4/10. Does that make sense? Yes, no? Okay. What does C do? What is that C value now? This time C is inside with your X, right? So instead of a vertical stretch or compression, we have horizontal stretches and compressions. And if C is negative, what's going to happen? This time it would reflect over the y-axis. Okay, so we talked yesterday, any moves that are inside the function with x are opposite of what they seem like they should be. So as my C value gets bigger than 1, what happened to my graph? It compressed. So it's opposite of what you're seeing. I see a 2 there, but my graph is actually half as wide. Now, that means our x's are being affected. So here, our x coordinate was at a 1. Now my x coordinate is at a half. All right, I'm just scrunching it down. My y coordinate did not change. I'm still at the same height. So one way to look at that is if you have a 2 in there, all of our x's have to be cut in half so that when we multiply by that 2, we're back to where we were. So to get the same y value out, we had to cut our x's in half. Okay? So what's going to happen as C gets smaller than 1? Now we've stretched it. Okay? So keep in mind, all of those things inside with x are going to move in the opposite direction that it seems like they should be. Okay? All right. I want you guys to take a look at the first example while I switch screens here and discuss at your tables. What kind of transformations do you see? All right. I would suggest writing this formula down in your notes packet at the top, just to refresh your memory. We always want our functions written in this format. Then we can identify our transformations and move left to right. So once again, our A value here is going to cause vertical stretching and compressing. And if it's negative, it's going to reflect over the x-axis. Our C value is going to cause a horizontal stretch or compression. and it's going to reflect over the y-axis if it's negative. Our h value is a left and right move, and our k value is an up and down move. Now, I do want you to notice inside the function here, notice that that c value was factored out of the x, away from the x. Does that make sense? You have to have it in that format to correctly identify the moves. Okay? So I'm going to pause the recording for just a second, let you get that copied down. All right, so looking at our first example, directions say to identify the parent function, the transformation, and graph it. So when I first look at this, what kind of function are we working with? Think about all those different functions we graphed yesterday. A square root. So we're looking at y equals the square root of x. That is our parent function. Do you remember how we plot points for that? I heard 1, 1, 4, 2, 9, 3. What's the end point? 0, 0. And it is important, I always make that a bigger dot. It's important that you know where your curve stops. Okay? So we have this square root graph. We want to do some transformations to it. There is something wrong with the way it's written. Y equals the square root of negative x plus 3 plus a 5. We have to take that negative that's in front of x and we have to factor it away. It's not coming outside the square root symbol. It still is an inside piece, but we do have to pull it away from the x value. Okay? So if I were to factor that negative out, what would be left? Okay? Agree, disagree? Does that look okay? All right. Now does it match the format we said it should look like? Yes? No? What's our a value? What's our a value? That's the one that's outside. What's outside the square root symbol? A 1, right? That means I do not have any vertical stretching or compressing or reflecting over x-axis. I haven't done any of that. What is my c value? That's a negative 1, which means what? Yes, reflection over y. Okay. Do I have an h value? Yes. So what is that going to do? Right 3. And last, up 5. And I have to go in that order. Because when I do reflections over the y-axis and I move left and right, if I do them in the wrong order, I'm going to land in the wrong spot. Okay? So that's why we factored that negative out so we could correctly identify the reflection and the move to the right. Okay? So we are going to take the points that we've already plotted and we're going to do these 3 transformations. Some people like to take all the points and do the first transformation on them. In other words, reflect them over the y-axis. Then take all the points and move them right 3. And then take all the points and move them up 5. I go through and do 1 point and move it till it's in its final spot. Okay? But either way is fine. Before you even start though, I'd like you to kind of have a visual of what you should be getting. Okay? So, very quickly, you don't have to draw this in, I just want you to watch up here for a sec. If I reflect this over the y-axis, I should have an arch going that direction. Yes? And then we're going to shift it right 3 and up 5. So I should end up with something over in this area. Would you agree? Okay. Now, let's start with each point. I'll start with my vertex, that 0, 0 point. Okay? I'm going to reflect it over the y-axis. What happens if I'm on the line that I'm trying to reflect over? Stays there. Okay? So, it hasn't moved yet. Then I'm going to move it right 3 and up 5. It's going to land there. Make that a bigger dot. We want to make sure we know that is the end of our curve. We don't go beyond that. Okay. My next point, the 1, 1 ordered pair. I'm going to reflect it over the y-axis. It's going to put me over here. Okay. Then I have to move it right 3 and up 5. I'm going to land there. Taking my 2, 4 point, reflecting it over the y-axis puts me over here, and then right 3 and up 5. And my last point, I'm at 3, 9. If I reflect it over the y-axis, I'm at negative 9, 3. Sorry, I'm at 9, 3. Now I'm going to be at negative 9, 3. And then I have to move it right 3 and up 5. And then draw it in. Now, on this one, there's only one arrow at the end, and we stop at that larger point, right? We don't go past that. So did it land where we predicted it would land? Okay. Let's look at our next example. We don't have quite as many transformations here. What is the parent function? An x squared. Good. All right, so let's go ahead and plot that. That is a parabola, vertex at the origin. What other points do we graph for our parent function parabola? 1, 1, 2, 4. And you can do 3, 9. You probably don't have to do all of those points. All right, the bottom 5 here would be fine. If we use those 5, that should be enough. Okay. Now, what kind of transformations am I doing? Is that an A, a C, an H, or a K in terms of our transformations? That is a C. It is inside the function, right? You said the function was a squaring function. It's inside. It's being squared. Okay? So that is a C value. Remember, all the things inside do the opposite of what you think they should do. Okay? So when we look at that, that 1/2 is going to cause a horizontal stretch or compression, right? It's a horizontal move. Anything inside with X moves things horizontally. It's a 1/2. We think it's a small number, which is actually going to make our graph get bigger, right? It's going to do the opposite. So think of it this way. I have to take all my X's and make them twice as big because this is going to cut them in half. So if I make them twice as big, the 1/2 will put them back to where they were. I'll get the same Y coordinate out that I started with. So to keep the same Y value, I have to cut my X's, or I have to multiply my X's by 2. So this is going to be a horizontal stretch. Your X's are going to be multiplied by 2. That means I'm going to look at all of my X coordinates and just make them twice as big. All right, so let's start with this first one here. All right, the point 2, 4. Its X coordinate is a 2. I need to make it twice as big. I need to make the X coordinate become a 4. It's going to have the same height, okay, but its X coordinate has been doubled. The point 1, 1. I'm going to double the X coordinate, which makes it go to 2, 1. What happens when you double 0? Stays the same, okay? If I double a negative 1, now I'm at negative 2. Same Y coordinate, right? Same height, but I've made my X twice as big. My last point, my X value is at negative 2. I want to double that, so I'm going to move it to negative 4. Haven't changed my Y coordinates at all. But look at what's happened to my graph. Have I stretched it horizontally? I've made it get fatter? Okay. All right, next one. What is our parent function? Good, square root of X. All right, let's plot our square root points. 0, 0, 1, 1, 4, 2, 3, or 9, 3. Okay. Now, what are we doing to those? I see a 2 in my function. Is it inside the function? So it is a C value, right? Not an A value. It is a 2, but everything inside moves opposite. So instead of making it get bigger, we're going to make it get smaller. This would be a horizontal compression. Okay? So there's a 2 in that function. That means all my x's are going to have to be cut in half so that when I multiply that 2 back in, I'm back where I started. Okay? So I'm going to multiply all x's by 1/2. All right, so let's start with 0, 0. What happens if you take 0 times 1/2? It's still 0. So my vertex, that end point there, didn't move. Okay? The point 1, 1. If I take the x-coordinate and cut it in half, it's only going to be at 1/2, comma 1. Correct? Okay? And my next dot is over with an x-coordinate of 4. Cutting that in half puts the x-coordinate at 2. My last point has an x-coordinate of 9. Cutting that in half would make it 4.5. So my curve, instead of being so stretched out and flatter, has been scrunched together. Does that make sense? Okay. All right. How are the next 3 questions different from what we've been doing? Is it as easy to tell the parent function? No. They've given you this generic f of x, okay? They've plotted it for you, so you don't have to plot the parent function. It's already graphed for you. And they're just saying, we're starting with some parent function f of x. Don't worry about how it was created. Here's my points. Okay? All you have to do is identify what are we doing to those points. So what is the negative in front going to do? Good. Reflect over x. Okay. What is the 2 inside going to do? Okay, so we're going to do a horizontal, and you do have to say horizontal or vertical. That is a horizontal compression. All of my x coordinates are going to get multiplied by 1/2, right? Because the 2 will put it back to where they started. So multiply x's by 1/2. And then what is the negative 1 on the outside going to do? Down 1. Okay, so again, before we even start this one, I want you to kind of picture, visualize in your mind. Right now, would you agree that it kind of looks like an M? Yes? Okay, so we have kind of an M-shaped graph. We're going to reflect it over the x-axis. What happens to that M if I flip it over the x-axis? It's going to look more like a W. Yes? Then it says we're supposed to compress it horizontally. So that W is going to get skinnier, and then we're going to move it down 1. Okay, can you visualize it? All right, let's see if our dots come out that way. Doesn't matter which one you start with. I'm going to start with the one on the far right here. So I'm working on this point. We want to reflect it over the x-axis. Okay, so reflecting it over the x-axis puts me up here. Would you agree with that? Yes? And if I were you, I would just hold your pencil where it should be, but don't actually make a dot because you're going to have too many dots on your paper by the time you finish to know where your final points are. Okay, so we're up here. Then it says compress it horizontally. Well, right now my x-coordinate is a 3. I need to times that by 1/2. 1/2 of 3 would be 1.5. So now it's moved to here. Yes? And then down 1 puts me here. That's my final dot. Okay? Let's move to our next point. We're going to start with this one here. What happens when you reflect that over the x-axis? Nothing, right? It's on the x-axis, it doesn't move. Compressing it to half its size. Right now its x-coordinate is 2. I'm going to move it to 1. So I'm going to be here. And then I have to move down 1. So I'm going to land there. Okay. Starting with this point. Reflecting it over the x-axis puts me up here at 1. Compressing it. What happens if I compress 0? Still there. And then down 1. So my final spot should be there. Okay. Next point. Reflecting over the x-axis puts me down here. Compressing it. Right now I'm at -2 for an x-coordinate. I'm going to compress that to half its size, -1. And then I'm going to shift it down 1. I'm going to land there. And my last point, reflecting over the x-axis puts me up here. Compressing it, I'm at a 4, sorry, -4. Half of that would be -2. And then down 1, I land there. All right, connect your dots. So does it look like what we predicted? Does it look like a W? Is it skinnier than its original graph? And is it moved down a little bit? Okay. All right, our next one. We have several transformations to do on this one. Notice that inside the parentheses, there is something right in front of that x. We have to factor that out. And when I say factor it out, I'm saying factor it away from the x, but it's still inside the function. Okay? So my function is now going to look like this. The negative is going to be factored away from the x, which makes the +1 turn into a -1. So that is an equivalent expression to what I was given, but it's in the correct transformation format. What kind of transformations do we have to do? The 2 is going to be a vertical stretch. So if we're stretching things vertically, we are changing which coordinate? The y. So my y's are multiplied by 2. Remember, outside stuff does what it says it should do, right? There's a 2 in front, we're going to multiply by 2. Inside, there's a negative sign. What is that going to do? Okay. Reflect over our y-axis. What is that 1 going to do? Right 1, good. And the last step would be up 3. All right, so we have a lot of moves to do. All right, I'm going to start with this point. I'm going to stretch it vertically. Right now it's at -2. It puts it down at -4. Okay, for my y coordinate. Then I'm going to reflect it over the y-axis. I am 3 spaces from the y-axis. I need to go 3 spaces on the other side. I'm going to land there. Okay. Then I have to move it right 1 and up 3. My final spot would be there. All right. Moving this point. Vertically stretching it. Well, what is the y coordinate right now? It's at 0, right? What does doubling 0 do? Still at 0. Okay. Then I'm going to reflect it over the y-axis. Well, I'm 2 spaces from the y-axis, so reflecting it puts me over here. And then we said right 1 and up 1, 2, 3. I land there. Okay, taking our next point. We're going to stretch it vertically by a factor of 2. That means instead of being down here at -1, I'm going to move to -2. I'm going to reflect it over the y-axis, but I'm on the y-axis, so that doesn't do anything. Right 1 and up 3. I took away a dot, didn't I? Was it there? Okay. Next point. Stretching it. It's at a 1. I'm going to stretch it up to a 2. Then I need to reflect it over the y-axis. It's going to land over here. And then right 1 and up 3. And then my last point, stretching it. So I'm at a -1. I'm going to go to -2. I'm going to reflect it over the y-axis. I'm 4 spaces from the y-axis, so I need to go over here 4 spaces. And then right 1 and up 3. I land there. I did it again, didn't I? Was it there? Okay. All right, connecting our dots. So thinking about what shape we should have had, we've stretched it. Does it look taller vertically, taller? Okay, we reflected it over the y-axis. So originally the M had a higher point on the left. Does that make sense? A little higher peak on the left. When I flip it over the y-axis, now my higher peak is on the right side. Then we shifted it right 1 and up 3. So it looked like it's where it should be. Okay. We have one more to try. We're going to get this in the right format, identify the transformations, and then I'm going to give you a few minutes to try and move your dots all by yourself. So what would I have to do to make this look like it's supposed to look? I have to take out that 2. So I'm going to factor the 2 out of the stuff that's in parentheses. That turns this 2x minus 4 into what? Good. X minus 2. The 5 on the outside didn't change at all? All right, so what is that first 2 going to do? Good. Horizontal compression. That means horizontals, x's. I'm going to make my x's be what? Half their size. All right, so multiply x's by 1/2. What's the next 2 going to do? Right 2 and then last? Okay, so I'm going to pause the recording. I want you guys to go ahead and move those dots. I'll be working on it as you go so you can check if you are stuck. All right, go ahead and check your graph. Do your dots look correct? All right, if not, make sure you ask questions as I'm coming around and grabbing your homework. There we go. Your assignment 7 to 31 odd, and then 45, 47, 73, and 117. I will get you some graph paper.